In the previous video, we saw there are a number of functions like isLnum or isDigit that checks the status of whatever parameter you pass it. So let's take let's take an example program that uses some of these functions. So in this program, we include the ctype.h file so that we can use these two functions, isLnum and isDigit. So we need that #include so that we can use these two functions. And what we do in this main program is, once we set up these variables x and y initialize y to 0, we have a loop inside which we keep getting characters from the standard input, and whatever we get in we store as an integer x and then pass that as parameter to isLnum. So that's what all of this is doing, is getting a character, storing it in using an assignment statement into the variable x, and then pass that variable x essentially into the isLnum function, which is true if this is a letter or a letter or a number. So as long as what this while loop does is check if each character we get is alphanumeric. If it is, then we check if it's a digit, and if it is, then we do this operation on y. And if you take a look at this, you might wonder exactly what this is doing. It turns out it's pretty simple. All it does is take a bunch of numbers and recreate from a sequence of digits what that number should be as an int. So I'll give you an example. Take a look at this program and compile it. It works, and let's run it. So the output is sort of deceptively simple. The program is a little bit more complicated than it looks, really. So if you type in 234, it just prints out equals 234. And so it's based on the what it prints out, it doesn't look like it's doing a whole lot. But what it's really doing is taking a sequence of digits and recreating one single number using this formula. So you can go through the details. Briefly speaking, this is what it does. Each character it gets, it stores an x, checks if it's a digit. So at this point we can be pretty sure, if you're in this if statement, you can be pretty sure it's something between 0 and 9. Then what you do in this expression is you take the difference between the character 0 and x. So since x will be anything between 0 and 9, it's in ASCII form, and so we convert from ASCII to an actual number. So if we have the character 0 in x, it'll be something like, I can't remember, but I think it's 30, but I'm not sure. So it will be whatever ASCII 0 is. So we're converting from ASCII to a number, and then we're doing y is equal to y times 10. That's just converting from an int and converting from ASCII, single ASCII number, to an int, and accumulating, the tens, hundreds, thousands, and so on. So it's doing quite a bit of work here, but despite that, the output is sort of simple in that it just seems like it's echoing what you're printing out, but it's not echoing. So let's try a bigger number, and that works. Let's try something even bigger. I think you know what the limits are. Let's try 2 billion. Just 9 zeros, that works. And of course, if you try something bigger, 1, 2, 3, 1, 2, 3, this tells you that the fact that when you enter something that's outside the range of an int and you get a negative number, that tells you that it's not just echoing out characters. It's actually doing some computation. In this case, it's figuring out that the number is too big to represent in an int, and so you get a negative number. Okay. So take a look at this. This is just an example of using these two functions, isAllNum and isDigit. And it does some computation to convert a sequence of characters that are all digits, converts them from ASCII to an actual int, to a single int. So it converts a sequence of digits to an int, something that might be handy further down the line. Okay. So this next example looks at essentially the main thing that we're doing here is using this toUpper function. And you can guess what this does. So briefly speaking, you have you're declaring a variable C that you're going to use later on to store the output of getC. F and G are two files. F is going to be opened in read mode, and this is, if you remember, one of our previous programs looked exactly like this, or very similar. Then you open up a file pointer G that will point you to an output file, test.out, which we open in write mode. And so if it doesn't exist, fopen will create it when you run this program. And then for each character you get, as long as it's not the end of the file, what it'll do is not just put C like we did before, but it'll convert it first from lowercase to uppercase. If it's already in uppercase, it doesn't do anything. So what does this do? It takes an input file test, converts all the characters, all letters, from lowercase to uppercase, and store it in a file called test.out. So try it out. Definitely want to try out programs like this to convince yourself that it works. Okay, so the main part of this this video will be about command line arguments. We talked about how to use command line arguments, and we talked about briefly how in Java we have a public static void main in which we have a single argument which is an array of strings. And remember, C does not have strings. What it has is arrays of character. And remember also that when you see a car star, you want to think, okay, whenever you see a car star, it can either be just a pointer to a character, or more likely, you can interpret this as a string. So if you just say, well, okay, I'm going to interpret this car star as a string, this means that argv is an array of strings, just like in the public static void main of Java programs. So next, let's take a look at what this is. What is this int argc doing? Remember also that in Java, every array has a public final int data member called length, which tells you the number of quantities in that array. C, however, has what you would call a raw array only. So all of these things, all arrays in C are sort of raw, in that you only have an array of things. You don't have this public final int data member. They're not anything like objects. So arrays in C are much more basic. So this argc is just a count. So the C stands for count, of the number of arguments. So what this number tells you is the number of things in this array. Okay, so what are the things you can do with this? For example, you can print out, remember %s is used to format strings, so this will print out the name of this program itself. So argv sub 0 is the name of the program, and so argv sub 1 is the first command line argument, so on. So this is very similar to shell scripts. In shell scripts, $0 is the name of the script itself, $1 is the first argument, and this is the same idea. Argv sub 1 will be the first argument, and so on. The next thing we do is printf, and print out is this string saying this program was called with so many arguments, and the parameter that we supply for this %t format character is the number of args minus 1, because the first one is the name of the program itself, so that's why we subtract the 1. So let's say we run this program and we supply 2 arguments. argc will be 3. You subtract 1 and you get the 2. If you run this program with no arguments, argc will be 1, so 1 minus 1 is 0, and we'll get called with 0 arguments. Okay. So once again, int argc is a count of the number of arguments including the program name, and this is an array of all the command line arguments including the program name. So let's take a simple example. Let's just take this very same code and we'll run it. Let's cat into lec 17.8.c. This is okay. It's a mess, but we can fix it. So we have an count of the number of arguments, and then remember char star is a string, and then if you have a char star that's a string, argv is the name of the array, and so this says that argv is an array of strings. Okay, so one thing that you want to keep in mind if you copy and paste from a PDF is that you might have, if you have tried doing this, you may recall seeing these kinds of errors. So get a whole bunch of warnings saying you have these stray characters. This is how to fix it. If you've ever run into this problem, you just replace each of these double quotes with a normal double quote, and you can see as I replace this, so 1, 2, 3, there's a slight change if you notice that. This might fix almost everything. So if just in case you ran into the same problem, you can fix it mostly by fixing the double quotes. Let's see if this works. Okay, we lucked out. And let's run this. So called it 0 args, 2, that should be 3, 4, and it doesn't matter if it's numbers or letters. I think I did 1, 2, 3, 4, 5, 6. Okay, there we go. So that's a quick introduction to command line arguments.